Good evening students. As I told you that in my next class I will teach you MOT, that is a molecular orbital theory. Okay. So what is molecular orbital theory? It when nuclei of two atoms come close to each other. Their atomic orbital interact resulting in the formation of a molecular orbital. In a molecule's atomic orbital lose their identity after the formation of a molecular orbital. What does it mean? I'm just going to tell you about some example. Suppose when nuclei of two atoms, okay, like suppose two atom of a hydrogen, okay, like this, or H2 like this. So two atom of a hydrogen, they all have a one electron with each, okay, one electron with each. So what here they told in a theory, when nuclei of a two atom come close to each other, okay, nuclei of a hydrogen, both hydrogen will come close to each other, their atomic orbital interact resulting in the formation of a molecular orbital. Now it change into molecular orbit, okay. So it will change into molecular orbit after having one electron, okay. So they took one electron and they change into molecular orbit. So now they just lose their identity, okay. Now they are not as a single hydrogen, they will not behave as a single hydrogen, not at all, okay. How they will behave? They will behave like a H2 atom, okay. So it behave like a H2 atom. In molecule's atomic orbital lose their identity. It lose its identity in a that way. It only react like a H2 form, okay, because they combine to form a molecule, okay, molecular orbit. So they behave in that way only. So in molecules, atomic orbital lose their identity after the formation of a molecular orbital. So they lose its identity like previous, how they behave or how they look, they just change their identity in a H2 form, in a molecule or molecular orbital form. They will behave in that way only, okay. So this quality of hydrogen and this quality of hydrogen have a not similar, they are not similar to each other, okay. Some of quality may be we can say that some quality are similar, but most of the quality will be not same. So they just change their identity also after when nuclei of a two atom come close to each other and their atomic orbital interact, like they will come to each other and interact to each other, and then they will create a molecular orbital, and their own identity of a single hydrogen will be totally exchanged into molecular orbital of a H2 atom, okay. So they will just change, the previous form of hydrogen will change into H2 form, okay. So second in a molecular orbital, second theory, what does they say? Each molecular orbit described by wave function, okay. So wave function seems like that. So after forming a molecular orbit, it just described with the wave function, molecular orbit wave function, okay. And psi square is known as a electron density, okay. So these things will work in our next class also. So just remember all the things, smaller things also, which I am explaining you, okay. So each molecular orbit described by wave function seems like that, okay. And psi square is a electron density. So we must remember all these things, okay, because we have to just mix this theory with other things also. So we will come to know about more and more higher theories also, okay. So third, what they say in a molecular orbit theory, that molecular orbit wave function is a psi, okay, associate with a set of a quantum number. Okay, set of quantum number, that is a set of quantum number. What is a quantum number? That is a NLMS, that is a quantum number. It mixed with a quantum number which represent energy and the shape of a occupied molecular orbit. Okay, so molecular orbit wave function psi associate with a set of quantum number which represent energy and the shape of a occupied molecular orbit. Okay, they will derive the energy and the shape of a molecular orbit. Fourth is molecular orbit follow Pauli exclusion principle, Hund's rule and Aufbau principle. I hope you just learn this all theory. If you don't know, then I will just prepare one more video for this Pauli exclusive principle, Hund's rule and Aufbau principle. Okay, so don't worry about these things. In my next class I will make a video on this all. Okay, so spin quantum number will be clockwise and anti-clockwise in a molecular orbital theory. Okay, so molecular it's a fifth point, and a sixth is a molecular orbital is equal to atomic orbital. Okay, so it's a not different. Okay, so electron number and everything are just the same, so we can say that a molecular orbital are just equal to atomic orbitals. Okay, seventh is molecular orbital wave function, that is psi associated with a definite energy value. So total energy is equal to sum of energy of occupied molecular orbit. So molecular orbit wave function psi associate with a definite energy value. It is for sure that it must have a definite value of energy. Like what previous it has energy, it will not lose somewhere else. Okay, so it just change into one form to another. So it has a wave function associated with a definite energy value. It has a definite energy value. That is the most important thing, that a definite energy value it has. A total energy is equal to sum of energy of a occupied molecular orbit. Okay, this is also important point. And 8th point is the last point. Each molecular orbit psi associated with a set of quantum number which represent energy and a shape of occupied molecular orbit. I think this one is repeated. I also told you here also the same thing. So okay, and in next class I will teach you Pauli exclusive principle, Hund's rule and Aufbau principle. Until then, goodbye.